Okay, we've got a couple more equations involving exponents. So exponential equations. So in the other video, we wanted to take these and rewrite them so that the base is the same. So with this, the first one, we've got a 7 and we've got a 3. So 7 is not a power of 3. So we can't really conveniently write it as 1. So we're going to have to do something else. So the fact that the exponential functions are 1 to 1, that implies to us that logarithmic functions are also 1 to 1, right? Because they're inverses of each other. So that means that logarithms are 1 to 1. So I'm going to write something up here, right? So we have that the logarithmic function is 1 to 1, right? So this is equal to this if and only if x is equal to y. Whoops, I ran off the page there. So we know that the logarithmic functions are equal, right? They have the same output if and only if they have the same input. Well, we can use this backwards, right? We can choose really any acceptable base, and I can start with two things being equal, and I can just tackle log base a on both sides, and it's still got to be the same, right? Because this function is 1 to 1. So what we're saying over here is I've got some number is equal to some other number. Okay, that's great. So that means that if these two numbers are equal, well, I can say that the natural log of this number would have to be the same as the natural log of this number, because we're saying up in the first step that these are the same, right? If these numbers are the same, then their natural logs would be the same as well. You can use common log here, or you can use log of any base you want, any legal base you want. Usually we're going to use the common log or the natural log because it's less to write. And we're kind of lazy and we don't want to write very much. Okay, so that's convenient because we've now got this power rule, right? If I've got natural log of some number raised to a power, I can write this power as a factor in front, right? The power rule, we can write this as a factor. So we got 3x plus 7, and then I've got natural log 7. And we can rewrite that exponent again as a power over here. And then we've got natural log 3. So yeah, check out that power rule because that's super convenient. Okay, well, it kind of looks like we went from something kind of complicated to something a little more complicated. But that's not quite the case. Usually we're sort of intimidated by this logarithm stuff, but at the end of the day, that's just a real number. That's just some number. So is this, right? It's like 3 or 7, they're just numbers. So we can operate with this like a number. We can't forget our end goal is to get these x's alone. So that's, well, what remains to be done here. So we can do that. So if I want to get this thing out of the parentheses, I can distribute, right? We can distribute this natural log 7 to both of these terms. We're going to distribute this natural log 3 to both of those terms. And then we're, kind of just going to do the usual stuff. So we want to get our x values together. So let's multiply this through. We got 3x times natural log x, and then I've got 7 natural log 7. And then we can multiply through here. I've got 4 natural log 3 minus 2x natural log 3. Okay, so now we want to get these x terms together. So I want to get this term together with this term. So we can add this one to both sides, and we can subtract this one from both sides. And then we're going to have the x terms together on the left. So we got 3x natural log 7. That didn't go anywhere. We can add that to both sides. And then we can subtract this from both sides. So we've got equal 4 natural log 3 minus 7 natural log 7. And now we're almost home free here, right? Both of these terms have our x's, and we can factor that on out. So now that's just going to be 3 natural log 7, and this is 2 natural log 3. And we got this over here. That didn't change. And now that x is now going to be by itself because we can divide everything by that number. So I got 4 natural log 3 minus 7 natural log 7 over that stuff. So 3 natural log 7 plus 2 natural log 3. Okay, so just to be clear here, there are a whole lot of different ways that I can rewrite this, right? We can use that power rule. We could tack this up there as an exponent. We could use this again and tack that up there as an exponent as well. But, you know, independent of how much we can simplify this stuff, here is our solution, you know, and depending on the context, we might want to simplify this a bit. But if we're not specifically asked to simplify this down, way down, we can be done here, right? So we can simplify this depending on the context, and maybe we'll need to, maybe we won't need to. But either way, we found the nice solution. How great. Okay, so let's look at this other one. That doesn't look the same, right? So if we were to go and try to pull this trick we did over here, we would want to get one of these on the other side, right? And then try to combine it with this. But, you know, maybe pause the video and give that a shot. You know, try to see if you can combine one of these with the 12. But, you know, it's probably not going to happen. So the trick with these, the trick is to notice that this has quadratic form. It's kind of sneaky in the way that it is quadratic form, but it is, right? We can rewrite these two things with the same base, right? 2. If I wrote this with a base of 2, I would have 2 squared to the x power, okay? And then I've got the rest of it, plus 2 to the x equals 12. Okay, so now I can rewrite this. I've got 2x squared, right? So we know that when we raise a power to a power, we multiply. We also know multiplication is commutative, so we can multiply whatever order we want. So these two objects are the same. And now we can hopefully see clearer that this has quadratic form. You know, maybe we can even do that substitution game. So if we say 2 to the x is equal to u, then we would have u instead of 2 to the x, right? So we've got u squared plus 2x, that's just u, equals 12. And now we've got a very, very clear-cut way to solve this guy, right? So we know that we have something of quadratic form, so that means we're going to factor it, right? We want to put everything on one side, 0 on the other, and now we can factor this, right? Two things that multiply to be negative 12 add to be 1. We would have, what, 3 and 4. So we got a positive 4 and a minus 3. So that tells us that either u is negative 4 or u is 3. Keep that separate. Okay, so that's great, but we weren't after u, were we? We were after 2 to the x power. So 2 to the x. 2 to the x. Okay. All right, so now we've got a couple other, so our first equation has somehow split into 2, right? So let's take a look at this one. 2 to the x equal negative 4. Okay, so this is hearkening back to when we first talked about exponential functions. We recall what the range of this thing was, right? So the range of an exponential here, if I've just got 2 to the x, this is always going to be positive, right? Any number I put in there is either going to be, well, it's going to be positive. It's not either going to be anything. It's just going to be positive, right? So we know that this one immediately has no solutions, right? Because 2 to the x is always positive. Right, and maybe recall what the graph looks like. Recall what the graph of y equal x, or excuse me, y equal 2 to the x. So that's always positive, so that can't be a solution, right? So this one, we are going to get a solution. And we're going to have to either rewrite these using the same base, and that's going to be inconvenient for us. So we're going to do what we did on this last problem. Let me take this down here so I can quit holding that there. So we have 2 to the x equal 3. All right, well, we can just pull the same trick, right? Take a natural log of both sides. And then we can use our nice power, yeah, that exponent property there. So that's going to tack down in front as a factor. And we're done. Divide everything by natural log 2, and there we have it. So we ought to go back. We ought to go back. I was off a little bit. Yeah, we ought to go back and plug that in there and verify that it does make it true. But we can leave that to you.